because the variables are not the same. So we have x plus y equals 3, and we have x plus 2 squared plus y minus 2 squared equals 5. So we will solve the first equation either for x or for y. It doesn't matter. Which one would you prefer? So we can do exactly what you did. I mean, x or y doesn't matter. Okay, so then x equals negative y plus 3, and we have to replace it here. Negative y plus 3. So negative y plus 3 plus 2 will be negative y plus 5, everything squared, and plus y minus 2, everything squared equals 5. So now we created an equation with only one variable, and that equation is quadratic, and I have to be careful how I square because I need to obtain how many terms when I square a binomial. Right, so the first term squared minus 2 times the first times the second plus 25, and the same thing here, minus 4y plus 4 minus 5 equals 0. So quadratic. Is this step okay? Okay, now combine like terms. 2y squared minus 14y, and this is minus 1, so plus 24 equals 0. The idea is to always simplify as much as possible, so I will divide both sides by 2. Y squared minus 7y plus 12 equals 0. And then I will factor into y minus 3 and y minus 4. And we get two options, y equals 3 and y equals 4. That's good, but that's not good enough. I have to find the corresponding x. When I plug in 3 here with minus in front, x will be 0. When I plug in 4 here with minus in front, x will be negative 1. So solution 0, 3 and negative 1, 4. Is this better? Any questions on this problem? Anything else that you would like to go back to from test 4? I'm sorry, test 3? My apologies, I forgot to tell you on my phone. I meant to, but I forgot. Sorry. It's done now. Yes, sorry. Which other? Yes. From the same test. Yes. Let's look at problem 10. Problem 10. 7, 8, 9, 10. Okay, 16 to x plus 9 equals 256 to x minus 7. So this is an exponential equation. So if you notice, although I'm not a fan of non-prime numbers, if you notice this is nothing else but, so 256 is nothing else but 16 squared. So both sides can be presented with the same base. The left-hand side stays as 16 raised to x plus 9. The other side stays as, changes into 16 squared to x minus 7. You didn't have to do this. You could have just applied log to both sides. But I think it's longer, and it's slightly more difficult maybe. So then 16 to x plus 9 equals 16 to 2x minus 14. Two numbers are equal and they have the same base. The exponents must be the same. X plus 9 must equal negative 2x plus minus 14. So I move negative x and I move and I get negative 23. So x equals 23. I recommend this every time both sides can be presented with the same base. If you can present with the same base, then you have to use log. If you can present with with the same base and you use log, will you get the same answer? Of course. Of course. But there is no need for that. It will take longer, but the answer must be the same. Good. Next question.
I'm hoping we could do another example like the number 18, the Gauss-Jordan.
Yes.
Yes.
So let's choose from the book. Any other problem? This is section 6.1. I was going to say 8.1, but no, it's 6.1. You want me to choose? Don't remember which problems we did. So if there is one that we have looked at before, then you can stop me and we can choose another. Yeah, I don't think we did 24. It doesn't seem like it, but 3y minus z equals -1. X plus 5y minus z equals -4. -3x plus 6y plus 2z equals 11. For Gauss-Jordan, it is mandatory that terms with x, term with y, z, the equal symbol, and the free terms are one under the other. Is this the case here? Yes, it is. So I don't have to rearrange anything. I can already write the augmented matrix. 0, 1, -3, 3, 5, 6, -1, -1, 2, -1, -4, 11. So this is the augmented matrix. Now, if you remember the sequence of steps, and we cannot deviate from it, is 1, 0, 0, 1, 0, 0, 1, 0, 0. That's the sequence of steps. We have no choice. Okay. Well, obviously, I have a 0 here, and I don't want a 0. What would be the easiest thing to do to get a 1 here instead of a 0? Swap the two, because it doesn't matter. The order of equations is not important, or the order of rows is not important. Very good. So 1, 5, -1, -4. And 0, 3, -1, -1, -3, 6, 2, 11. By doing so, I already accomplished two things at once. I have the corresponding one that I needed, first row, first column, but I also have the 0 already underneath. The only task for column 1 is to obtain the 0 here now. And I know which row I have to multiply. Yes. So we multiply the first row by what and add it to the third row. Yes, very good. There is no other number but 3. Very good. So then which row do I have to copy, because it will not change at this point? It may change later, but not right now. Yes, because it's the row that I'm using. Good. And now it happens that I copy the second row as well, because the 0 is already there. So now let's do this together. 1 times 3 minus 3. Very good. 5 times 3 plus 6. Very good. -1 times 3. -3 plus 2. Very good. -4 times 3. -12 plus 11. Good. I have no idea what the answer is. I'm just going to make sure that I copied everything correctly. Just one more time. It can be as weird as possible. It doesn't mean anything. I'm just making sure that I copied correctly. Yes. And here I copy 0, 3, -1. Yes. -3, 6, 2, 11. Yes. And then we copied this as the second. So I should have written here, and I didn't. My apologies. Row 1 becomes row 2, and row 2 becomes row 1. And that's what we did. Yes. 0, 3, -1, -1, and -3, 6. Good. So 3, 0, 15, 21, -3, -1. Good. Okay. Perfect. Well, I have no choice now. I really don't. So this is accomplished, but now I'm here. And I need a 1 in there. I could never swap again with this, because if I swap, then I destroy this column. I could swap these two, but it's not going to make any difference. So my only chance now is to divide, or the next step would be to divide row 2 by 3. So 0, I'm sorry, not 0, it's 1. 1, 5, negative 1, negative 4, 0, 1, negative 1/3, negative 1/3, 21, negative 1, negative 1. Now I am working on these two numbers, and they eventually have to become 0. So obviously I have to multiply which row? It must be row 2. I'm done with row 1, then I continue with row 2, and then I continue with row 3. And I add it to row 1, and I add it to row 3. This is the key. Like it was here. This is the key for this column, so I can get the zeros. Now this is the key that will help me determine the zeros, or get the zeros. If I don't have this 1, I cannot get the zeros. So what do I multiply 1 by to eliminate the 5? Good. What do I multiply 1 by to eliminate the 21? Very good. Awesome. Great. Which row do I copy now? Of course, that's the one I'm using right now. Very good. So let's do this together. 1 times negative 5 plus 5. Perfect. Now careful now. Negative 1/3 times negative 5 is 5/3, but I have to subtract 1. And that makes it 2/3. Again, negative 1/3 times negative 5 is 5/3. And minus 4, I need to multiply by 3. So it's 5 minus 12 over 3. Negative 7/3. Is this okay? Now, 1 times negative 21 plus 21. Negative 1/3 times negative 21, that's nice. It's 7 minus 1, 6. I have here the exact same operation, so this must be 6 as well, because it's negative 1/3 times negative 21, which is 7 minus 1. So this is done, and it cannot be damaged. If I damage that, I'm going backwards, and I don't solve. Now I like it. I like what I see. What do I see? And what do I have to do?
The final row, you have to make the value of 1. So 5 by 6.
Perfect. So 1, 0, 0, 0, 1, 0, 1, 1, negative 1/3, negative 1/3, 2/3, negative 7/3. Okay. Obviously, we are at the stage in which we have to multiply which row? We had stage 1 when we multiplied row 1. We had stage 2 when we multiplied row 2. Now, obviously, there is only one left. So it's row 3 that needs to be multiplied by something and added to row 1. And row 3 multiplied by something and added to row 2. So what do I multiply 1 by to eliminate 2/3? Very good. What do I multiply 1 by to eliminate negative 1/3? Very good. And this is the very last step. Which row do I have to copy now? Right, the row I'm using. Okay, very good. 1 times negative 2/3 plus 2/3. 1 times negative 2/3, that's negative 2/3, and minus 7/3 is negative 9/3, which is very good. 1 times 1/3 minus 1/3. 1 times 1/3 minus 1/3. So the solution appears to be, we can't be certain just yet, it appears to be good. I don't trust it till I go back. 0, 1, negative 3, 0, 1, negative 3, 0, 1. 3 times 0 is 0, minus 1, minus 1. Negative 3, this is 0, negative 3, minus 1, negative 4. Positive 9 plus 2, 11. Yes. So now I am absolutely certain that this is the correct answer. And no one can find another. This is it. I'm sure there must be one in this in the previous final. Yes, there is one on page 9, number 13. Okay, so let me answer all the other questions you may have on test 3. Anything else? Anything else? Okay, are we ready to go through this, whatever you want me to? So I'm hoping that today and on Wednesday we're going to do this. I set up a review, but the review in the sense that you come in and you say, I want to see this problem, and we work on that problem. On Saturday, this Saturday, December the 8th, in this room, from 11 till 12:30, 11 a.m. till 12:30. Also, my calculus class will be here, so I will alternate. You say one problem, they say one problem, and we'll alternate so I can answer all your questions. I will not have a packet and say, hey, let's do this problem. I want you to come with questions. So make sure that you review all tests 3 or 4 times with solutions. So you can say, oh, I don't remember this from test 1, or I don't remember this from test 2, so we practice, okay? So what would you like to work on from these problems? We did last time, I'll tell you what we did. We looked at the equation of the circle. So this was done, but it doesn't matter. We can do it again. We also looked at exponential. So exponential and log. We looked at these. We did a similar problem with Gauss-Jordan. These were done in this test, but it doesn't matter. We can work on any problem here. From the previous tests, what else we looked at? We looked at simply find a difference quotient, and we looked at a rational equation. We did not look at this quadratic or radical yet, or absolute value, and we did not look at inequalities. And we did graph a piecewise-defined function. So let me know what you would like to continue with. Anything. And it can be one of those. I'm just emphasizing what we covered. Yes, please, Marcus.
Problem 2, letter B.
Problem 2b. Let's take a look. Also, I'm hoping that by Sunday you will finish up the math lab. I don't want to start putting zeros in there, because I don't want that. I just want you to work on those problems, please. Is that okay? Can you finish it up? You said 2b. Yes, this is a compound inequality. Is this the one? Okay, very good. So how do we solve this problem? As you see, this test was split so that 33% for test 1, and 33 for test 2, and 34 for test 3. So, and I do look at, by comparison, how you did on the previous tests. So if from test 2 you do well on the final exam, I will consider that when I look at the final grade. So please make the effort. It's just one more week, a week and a half for you to finish strong, please. Okay, any suggestions on something like this? What do we want to get rid of first? We are solving for x. So what is the idea? We would like to, it's a compound inequality because there are basically two inequalities. But we can solve them without splitting them apart. And it's recommended. Exactly. Of course. We have to get rid of the denominator. So we multiply everything by 3. So this is negative 9 less than or equal to 2x plus 5 less than 18. The next step would be to subtract 5 from all three sides. So I have negative 14 less than or equal to 2x less than 13. And obviously the final step would be, so negative 7 less than or equal to x less than 13 halves. In interval notation will be negative 7 gamma 13 halves with parentheses, so x in. Now your final exam will be exactly like we had the previous tests. So I will print it out from my math lab because you may find some hints in there, so it may help you. So I will do that. Is this okay? Do we remember this? Okay. So please choose the next problem, or if you would like to make up your own, or if there is something you don't see here, you can let me know. Yes, of course. The absolute value of 3x plus 2 greater than or equal to 2. So I can mark this. Very good. So remember, there are two inequalities with absolute value. One of them says in between, and the other one says outside. Which one is it? Because it doesn't need any simplification. It's completely cleaned up. So what will this mean?
The absolute means it's a distance from 0, right?
Yes.
It's either between -3 or +3.
If this is less than or equal to.
You're right. It's greater than or equal to. So
Yes.
every value except those.
Yes, outside.
Yeah.
So 3x plus 2 greater than or equal to 3, or 3x plus 2 less than or equal to -3. So on the real line, this is 0, and this is -3, and this is 3. I want this, and I want this, where the numbers have a distance from 0 bigger than 3 units. So then this is 3x greater than or equal to 1, because I subtract 2, and I divide by 3. So this is the first inequality, which will be this side. And now on the other one, I have 3x less than or equal to -5, x less than or equal to -5/3, which will be this side. All I have to remember is that the solution must have the union in between. So this will be -∞, -5/3, which is this side, and union 1/3 to infinity, which is this side. Does it make sense? Okay. I strongly recommend, since we may be able to finish everything here, but if we are not, please look at all these problems before you come back on Wednesday and ask questions after you review the previous tests with solutions. So please let me know what you would like to continue with. And it can be from the ones we covered last time as well. It doesn't matter. Which one? Yes, Marcus, please. Number 4. So let's take a look at number 4. The piecewise defined function? Okay, very good. So for the piecewise defined function, we have f of x, which is 4 minus x squared for x less than 1, or x plus 5 for x greater than or equal to 1. Allow me, before I forget, to remind you about the student opinion forms. Past Sunday, you will not be able to access them anymore. This is the last week. So if you please find the time. I got yours. So if you...
Is the test with those 5 points?
Yes.
It's from there.
No, I did not add them yet. As I promised, I will. Oh, absolutely. Okay, so this is a piecewise defined function, and the first thing I have to do is change this into negative infinity 1, and change this into the bracket 1 infinity. Why I recommend this is because, number 1, it gives you the domain of the function, and number 2, it enables you to get the chart going, the table going, and I hope it's a reminder for you to put a parenthesis facing left under 1, and the bracket touching it facing right under 1, which I think is important because you will know what's happening at that point. This point, x equals 1, or I should say this x value, x equals 1, is very important because at that point the function changes from one to another. Okay, so now I make myself a note, although it's redundant, but I'd rather have it and see it here. And then greater than or equal to 1 is x plus 5. I know how this looks like. It's 4 minus x squared, which means x squared, and then flipped, and then up 4. So I know it will cross at negative 2, and it will cross at 2, but 2 is not, don't rush, like I just did. Got carried away. It will not cross again, because 2 is here. So, and when x is 0, this is 4, and I have to plug in 1. Although you would say, but you're not allowed to. I know I'm not. But I will plug in 1, and I will leave this point as an open point because of the parenthesis. And then on the other side, I have 6, and at 2, I have 7. That's pretty much it. But now I'm ready to graph. Any questions on the points, on the ordered pairs? Any questions on the ordered pairs, please? Is this okay? So then, I know one more time that this graph should look like this. 1, 2, 3, 4. This part should look like this. Right? 4 minus x squared. But at 1 is 3 with an open. So I have negative 2, 0, I have 0, 4, and I have 1, 3. Now the other side is 1, 6. So I'm going to say 6 is right here. And then 7 is here. And I'm sure you have never seen this before. How are the graph on one page and the other half on another? So, because I should have graphed the coordinate system lower on the next page. So can anyone give us the range? Be careful. Because the function turns here at 4, and then here it starts at 6. So what will you say about the range of this function?
All the numbers.
From negative infinity till 4, union 6 to infinity. So negative infinity to 4 with a bracket, union with a bracket, 6 to infinity. Very good. Good pick. Next problem.
Can you do the problem before this problem 30 about the quotient?
Yes, of course. So here we have f of x negative 2x squared plus 7x minus 11. And they're asking us, the problem is asking us to find the difference quotient, which is given to us as f of x plus h minus f of x divided by h. Okay, so what piece do I have to work on before I put everything together?
FX.
F of x, I can't do anything to it, I will just copy it. Yes, this is the only piece I need to work on. This is clear. This is the one I don't have. So for f of x plus h, what do I have to write at least preliminary? And then I'll figure it out.
You replace all values of x for x plus h.
Very good.
Negative 2x plus h squared plus 7x plus h minus 11.
Very good. So I have to expand this, and I know, and I reviewed this from the first day of classes. What is it?
With x squared plus 2hx squared.
Very good. Plus 7x plus 7h minus 11. And this is negative 2x squared minus 4xh minus 2h squared plus 7x plus 7h minus 11. Only now I can put all these pieces together. And now I think for a moment and I say to myself, okay, what does have to happen? What has to happen here with this? And I will say, number one, all terms without h from the top must go away. And eventually, at the very end, the h from the bottom must go away somehow. Good. So I copy 2x squared, negative 2x squared minus 4xh minus 2h squared plus 7x plus 7h minus 11. And when I subtract the function, I have to change all signs inside because I subtract, I distribute negative 1 to all terms. So positive 2x squared minus 7x and plus 11. And I meant to say this, Brian, earlier, that half of Math 230 is based on this. So I'll simplify these two. Of course, I'll simplify these two, and I'll simplify these two. So I see that there are 3 terms left. And I'm really hoping that they have something in common, because otherwise I made an error somewhere. What do they have in common? They must. Because that h will simplify with the h in the denominator. Good, perfect. So then what is left in parentheses at the top? And it has to be 3 terms. Good. So then the answer is negative 4x minus 2h plus 7. And this is basically the rate of change of a function at any point under certain conditions, when certain conditions are fulfilled. Good. Next question. Next question.